Hello 108 students, Mr. McHugh here. Welcome to Chapter 6 on factoring, and we are going to go ahead and tackle 6.1, the first section of it, and we'll take care of that first page. Okay, one thing I want you to keep in mind, what does the word factoring mean? And I want you to think of one operation. If I asked you to take the number 12 and ask you what are factors of 12, meaning what times what equals 12, you could tell me 3 times 4. Each one of these would be a factor. 1 times 12, 2 times 6. So factoring means multiplication. That's the big thing I want you to get going here in your mind. And factoring is the process of taking a polynomial and writing it as the product of 2 or more simpler polynomials. Okay, now polynomials have got addition to it. Factoring means you will write them as the word product means you have multiplication. Okay. Now to get this process going, I want to come back and review something you guys have done hundreds of times, and that would be basically the distributive property. And with the distributive property, you're used to looking at a set of parentheses. You know your secret decoder ring tells you that there's multiplication going between 2, which is a factor, and the parentheses 3x plus 4. Alright, so there's 2 terms. Here's the first one, here's the second one. You multiply them both together, what's the result? 6x plus 8. Okay, you've done that hundreds of times. What is tougher to see is what I like to call reverse distributive property, meaning can you take this and come up with 2 factors and multiply together, they give you 6x plus 8. Now the secret to this is figuring out what's known as the greatest common factor. What goes into 6 and 8 evenly, the highest number? The answer is 2. So you quote, pull out a 2 out of each of these. You put the 2, you put yourself a set of parentheses and say 2 times what is 6x? Answer 3x. 2 times what is 8? And the answer is 4. Thus you've gone in the reverse direction of distributive property. This process here is factoring. Okay, now I used a term called greatest common factor. It's what is the largest term that you can be taken out of each term of the polynomial. Okay, that's what you want. You want to remember that it's the greatest. Now it can be numbers and it can be variables, letters. Okay, so let's just kind of work our way through some examples here. Rule number 1, I'm going to say this probably 100 times, when you do factoring, is always look for and pull out the greatest common factor. Rule number 1. Okay, so let's practice this. Look at 9z minus 18. Now, can we look at both the coefficients or the numbers and figure out a number that will go into 9 and 18 evenly? And the answer would be 9. 9 goes into itself once, 9 goes into 18 twice. Okay, now you pull out the 9. That's what the GCF is. Give yourself a set of parentheses. You're doing multiplication here. Now we don't write the dot, but we know it's assumed there. 9 times what equals 9z? Answer z. 9 times what produces negative 18? Answer negative 2. So if I would take the distributive property to wherever you think the 2 factor terms are, it should boomerang back the original problem. So look for the GCF. Rule number 1, like I said, what is the biggest term? You pull it out. Notice multiplication's going on. Okay. Let's try 1b here. Okay, now this factoring, I want to say here, we are basically doing some warm-up exercises this chapter. We got to learn how to factor and keep on factoring till the cows come home. You must master this. There's a little bit of trickery to it, but you got to get comfortable and use the different methods that we use for factoring through this chapter. Okay, so as you're going through, you go, why am I factoring? Why am I factoring? When we get to chapter 7. And we start doing rational expressions. I'm jumping the gun a tab. I'm just trying to give you some reasons why we will do factoring to set up reducing rational expressions. Okay, so that's chapter 7. We got a little ways to go. But let's look at 56m plus 35p. Now they say factor. You got to tell yourself, can you pull out a greatest common factor? Look at 56, look at 7. What number goes into both of them? Fortunately, your multiplication tables pay off. So you know 7 times 8 is 56, 7 times 5 is 35, so you pull the 7 out. And what's left that you need to multiply to come up with the first term? 8m. 7 times 8m is 56m. 7 times 5p is 35p. So there you go. There's the factored result. Okay, now you look at number C and they go, oh, factor this guy. Now that's a y class, by the way. It's 2y plus 5. And look at 2 and a 5. Can you pull a GCF out? Is there a common factor in them? And the answer would be no. Now when you pull out of variables, we're going to practice this here real quick. The variable must be in both terms. There is none, so therefore you can't be factored. Already simplified. Nothing to do there. Okay, so we're kind of cruising here, looking at example 2. Let's see if we can take an example like 2a. Two terms, 9x squared plus 12x squared. Look at the coefficients. Can you pull out a GCF? Answer is 3. Okay, I'm sure you guys are getting the idea here. Now look at the variable. You must have the same base variable. Whenever you have that in all the terms, you pull it out by definition. Hint, look at the exponents and pull out whatever one is the smallest exponent. That's the one you're going to use because it's got to be in both of them. Remember, x to the third equals x to the squared times x to the first. 2 plus 1 is 3. Remember, when you multiply by the same base, add the exponents. Okay, so now you can pull out an x. You pull out the square because it's the smallest exponent between the two of them, and then give yourself a set of parentheses, and now ask yourself, 3x squared times what produces 9x squared? Answer 3. 3 times 3, 9x squared. 3x squared times what gives you 12x to the third? Now watch this. 3 times 4 is 12. X squared times x to the first. When you multiply by the same base, I just said it, add the exponents. 1 plus 2 is 3. Okay, so you're probably getting the idea. These are examples of reverse distributive property. Look at example E here. Okay, 25 x squared y to the third. Okay, now we've got two variables. Over here you've got 30 y to the fifth. I notice there's no x variable, so therefore you will not have an x in the GCF. It has to be in all three terms. Third term, 15 y to the fourth, y to the seventh. Okay, so first recommendation, look at all the coefficients, 25, 30, 15. They usually make these fairly easy. Usually you see the 5 comes out, it goes into each of these evenly, highest number. Now I already mentioned you do not pull an x. Look at the variable y to the third, to the fifth, and to the seventh. Okay, now who remembers what you pull out? Which exponent? 3, 5, or 7? Hopefully you remember it as the smallest one. So you pull out 5 y to the third, give yourself some parentheses, figure out 5x to the third times what produces the first term? Answer 5x squared. 5 times 5 is 25. X to the third x to the third times y to the second produces that. Over here, multiply by 6y squared produces 30y to the fifth, and 5y to the third times negative 3x to the fourth, y to the fourth. X to the fourth, y to the fourth. Okay, there is no x, so you bring it in there. Look at the y. Y to the third times y to the fourth, add the exponents, produce the 7. And I got a note there for you too. Okay, we've done page 1. We're just getting started in section 6.1 factoring, so we got more work to do here. So I will see you on page 2, and we will do some factoring out parentheses or binomials. Okay, Mr. McHugh signing off for now. I will see you on page 2. Bye.